Okay, understanding calculus in 10 minutes. Okay, so that's the topic of this video. Now, notice the video isn't saying, or my topic isn't, or title is learn calculus in 10 minutes, or master calculus, or totally, understand it completely. Just basically understanding calculus 10 minutes, like understanding what it is. That's what the whole point of this, and really my kind of main goal here is to kind of maybe demystify what calculus is and lessen the intimidation factor because there's a lot of students out there that say, "Oh, I could never do calculus; it's too complicated," etc. And there is a lot to learn in this topic, but hopefully you'll kind of see the big picture here. But let me just, before we get into it real fast, let's just talk about where you would take calculus as a math student. So generally in high school, okay. So in high school, for most students, you start off with Algebra 1, then you go to Geometry, you go to Algebra 2, and then you go to Pre-Calculus in your last year of high school. Now, some students accelerate this and they'll actually end up in Calculus in their last year. Now, when you go to college, I would say maybe about 70% of the majors, degrees in college, right? So at the university level, many of them, I mean, well, definitely over half, are going to require you to at least have one semester of calculus. So if you don't take it in high school, you'll see um, a little bit of it in college. Now, if you're some sort of science or technical major or finance or whatnot, you'll probably take even more of it. So it's probably going to be in a lot of your futures if you're going the college route. Okay, so that's just basically where it lies in the spectrum of learning. All right, calculus in 10 minutes. Let's get right to it. So calculus basically helps us figure out kind of two problems, two kind of things in math. I'm going to start with one that's kind of easy. And that would be like the area and volume problem. Okay, so just going to sketch out here real quick. So this is like a rectangle, right? So if I said find the area of this rectangle, we have a formula for this, if you recall. So it would be like length times width, right? So the area of this rectangle is going to be the length times the width. No problem, okay? So we know this because we were given a formula. Let's do a circle, all right? What if we had a circle, and this is not a perfect circle, obviously, but if I said find the area of this circle, hopefully, some of you out there, or maybe most of you, remember there's a particular formula for this. Okay, it's pi r squared, r being the radius, which is like from the center out this distance, and pi is a number of 3.14 approximately. So I can use this formula to figure out the area of this circle, and for this rectangle, I could use this formula. Now, let's just do one more example. What if I had a triangle? Okay, so again, if I wanted to know the area, this would be uh, 1/2 base times height, right? So this would be the base of the triangle. This would be the height. Okay. So formulas help us find the area. And by the way, this goes for volume as well. So these formulas come in handy with these kind of basic figures like triangles and circles and etc. So let's take a look at where calculus helps us out. Okay, where it's a tremendous value. And by the way, I can't overstate the importance of calculus in mathematics, engineering, science. I mean, it's huge. Really is as powerful as you may think it is. Probably more so. All right. So what if we had some crazy figure like this, for example? And I'm just trying to draw something. Okay. So what if I said find the area of this particular object or this figure? Well, probably you're going to be looking for a formula, right? You're going to be, okay, yeah, I could find the um, area of this. Just give me the formula. Well, guess what? There is no formula for something like this. This is very challenging, okay? So calculus helps us figure out the area of crazy looking figures like this, okay? And volume. They don't have to be as, you know, abstract as this, but this is what calculus can do for us. This is the power of it, because without calculus, we would have to go through and just kind of like maybe try to estimate the area of this particular thing. But calculus can give us the exact area. Okay. Now, let's suppose that I took um, this figure, and let's kind of put this like on an axis. Okay. And I circled it around, spun it around. So we was kind of doing this business. Now, I don't know what it would exactly look like, but it might look like an object, maybe something like this, kind of maybe sketching this out. All right, and then it looked like it would have some sort of hole in the middle, right? Maybe like this type of deal. Very difficult to kind of maybe imagine, but you can see if you did have this, let's kind of fill this in a little bit. Right, and then you just kind of rotated this around, you would create some sort of weird looking figure like this. So this figure, you would be looking for the volume, right? Like how much water would be able to fill this particular, let's say maybe it's a vase or something. You could put in, okay? Once again, calculus will tell us exactly how to do this. And you may think, wow, you must have to go through all kinds of crazy advanced calculations in order to do that. And surprisingly, it's really not as bad as you think. Okay, once you understand the steps, you can do it. But you can see the power of being able to figure this stuff out. Let's go ahead and take a quick look, a real basic example on how we find area and volume in calculus. All right, so maybe some of you out there have already taken algebra and whatnot. I'm just making a real quick XY axis. All right, let's kind of maybe draw a little figure like so, okay? All right, so let's suppose I wanted to find the area from here to here underneath this curve. All right, let's say this area right here. All right, let's say this part underneath this curve, I wanted to find the area. So that shape, if you look at it, it's kind of curves on top, right? And it goes down. So you would be asked to find the area of this object. Okay. Once again, you're looking for a formula. There is no formula that exists. Now in calculus or in mathematics in general, okay, what we have when we have curves and things, we have little things called functions. All right, they basically just describe the curve. So this curve could be described by this x squared. Okay, you don't really need to know that right now because that's not the purpose of this video. But this little rule right here just describes this curve. This is the rule that tells us that this is the shape of this is described by this particular rule. Okay, we call these things functions. So as long as you have uh, this function or the description of this curve, okay, then we can use calculus to find the area. So let's say on our little graph, this is, let's say 1, this is 2, let's say this is 3, 4, and 5, okay? So the way we would do this is we would go ahead and have this little crazy symbol, okay? You might have seen this before. It's called the elongated S, but it basically means the sum, okay? And I don't want to get too far into it because that's not the purpose of this video, but we're going to say is, hey, we want to find the area underneath this particular curve, and I want you to start from 2 and go to 5, all right? So that's how we write that, okay? Then we put a little tiny little dx here. That will be kind of like in my part 2 of this video here. Well, I'm gonna get to that in a second, okay? But this is the setup, all right, to find the area underneath this curve, okay? You're saying, well, yeah, that looks pretty complicated. That's fine, but really, and the steps to actually find the area are not complex at all. What we do in calculus, once we write this out, this long thing, you can kind of think of this long symbol, this elongated S, is find the area. Like find me the area underneath this particular curve, all right? That's all it means. This is from the left side of the curve, and this is to the right side. Not difficult, right? This is the description of the curve. Once again, if we're given it, not difficult, okay? So what we do now, okay, is there's a little rule that says take this number, this exponent in this power, we just add 1 to it, okay? So we're going to keep that same variable, add 1. So 2 plus 1 is what? 3. Pretty simple. Then whatever that result is, we're going to divide by that number, okay? So all we're going to do is take this right here, and we're going to use this to find the area. And the way we do that is the following, okay? We're going to subtract, we're going to use this thing, all right, and we're going to subtract the following, okay? We're going to plug in 5 over here. Okay, we kind of start from the bigger side. So we'll plug in 5 cubed, right, from our right side. And I'm not going to get too far into it. And then we're going to plug in from the left side like so. And when we do this little calculation, okay, we're going to actually get the area. So it's really not difficult in terms of the mathematics involved. I mean, if you've taken basic, maybe even pre-algebra, middle school math, you could figure this out, right? I would just, obviously, I'm telling you the steps. Now, what makes calculus more complicated for people is that these curve descriptions, these little curves and these functions, you can get more complicated, okay? So when these get more complicated, you have to learn more rules. But it's really a matter of just learning the rules to get to this part, okay? So that's the big deal. This is like part 1 of calculus, okay? Now, calculus, like I said, there's like 2 big problems it solves for us. So that's the first problem, area and volume. Let me erase this, and then we'll get into the second cool problem, all right? Right. So the second thing calculus does for us, and let me go ahead and draw a little XY plot here, is calculus helps us determine how steep, okay, something is, what its slope is, all right? And what do I mean by this? Let's suppose from here to here, I wanted to know generally how steep this line is going from these 2 points. So I could say, well, it's kind of going this direction. Now I'll get into why this is important here in a second. We want to know the direction of curves, okay? We want to be able to get their steepness because they're always changing. If you study this curve is always changing. This could be, for example, just imagine this can be anything you want it to be. It could be population growth, right, over time. All right, let's think of it that way. This could be a stock that's going up in time. This can be maybe the rate of maybe cancer in a particular city that's going up in time. So when we have what we call like rates of change and things are constantly kind of maybe growing or they're fluctuating, we want to be able to estimate between time periods or between blocks of the curve, it's the steepness, okay? Because this gives us an indication of where things are going. You could tell here the steepness is different here versus where, let's say, at this point in this particular graph, okay? So the steepness is always changing, all right? We call this steepness. I kind of like to use the word, I'm using step, but it's really steepness, okay? That my word is, but actually the technical word is slope, all right? That's probably a better word for you anyways. So it's the slope of the curve. Like, hey, now where is it so what's its actual slope? Now, you can figure out the slope if you have 2 points that are on the curve. It's pretty easy, okay? Because effectively what you're going to do is just determine like these 2 points, I can just figure out the rise, and that's just this amount right here over the run, okay? So the slope is defined by the rise over the run. So if I can get those 2 measurements, it's no big deal. I can just figure it out, and there I go. But here's where calculus really becomes powerful, okay? What happens when we want to know the slope of a curve? And I'm going to draw a new curve here to make this a bit more pronounced. Okay. Maybe something like this. Okay. So we can see that the slope here is kind of going, it's kind of doing this, and then it's kind of like going this way, then it's kind of going this way, and then it's going down like so, right? So the slope of this curve is constantly changing. Now, what if I want to know the exact slope of this curve at this point right here? Okay, that point. Well, by definition, the slope, we need the rise and run. We actually need 2 points. Like here, I can kind of estimate it, right? If I take 2 points, it's kind of going in this direction, okay? Kind of something like that. But if you notice, if I put another point right here, it's kind of going like this. So, I'm getting different estimates, but I don't want to estimate. I want to know the exact slope right on one point of a curve, okay? And you can think of this as the exact rate of change in one precise moment. All right. So let's think of this as time. Okay. And maybe this is population growth. I want to know the exact rate of population at this exact time. Maybe it's May 8th of whatever year, okay? At what particular time. You want to know exactly. You don't want to know an estimate. Kind of goes back to our area and volume problem. You can get estimates, but not the exact answer. Well, calculus helps us determine the exact answer. Because in calculus, we can determine the slope. Now, once again, what we need is the function, okay? Let's say, and this, for those of you out there, this is not an actual the actual function to this curve. I'm just using this for simplicity's sakes. But let's say I had this function described by this rule. Okay. Now remember, we use these function descriptions as when we're trying to find an area and volume in calculus. But here we have something called a derivative. All right. And the derivative basically it's a rule, okay, that allows us to find the slope at any point, any exact point along the curve. And that symbol looks like this. It also looks like so. All right. This is another symbol in calculus, dx over dy. And there's even other ones, f prime, etc. But these crazy symbols are the derivatives. So let's take a look how I would find the derivative of a function of 2x squared plus 2x plus 1. Right, so what we call this actually the first derivative. So all we do is we multiply this exponent 2 times this coefficient, this number. So 2 times 2 is what? 4. We keep the x and then we subtract 1 from this 2. So that's just x to the first, or just x. Now we go to the next guy and we do the same thing. So this x here, there's actually a little 1. We don't write it, but there's a 1 up there. So 1 times 2 is 2, and then x here to the 0. So that's going to be just x to the 0 power is just 1. So this is our first derivative, okay, of this particular function, this curve description. And this is a rule to tell us the slope of the curve anywhere along the curve, okay? But you can see here, what I just did, the mechanics of finding this are really quite easy. Once again, it's a bunch of rules. So I can use this, I'm not going to get into this now, but I can use this here, this particular rule, to easily find the precise slope at this moment in time. Okay, and this helps us solve tremendous problems in mathematics. Okay, here let's kind of first of all, let me kind of clean this graph up. Let's say you wanted to know, let's say we're doing some sort of scientific study. Actually, we do the better curve, and let's suppose this is maybe some sort of medicine or pharmaceutical drug that you're testing, okay? And you want to know, like, hey, wow, this is where it's decreasing, the symptoms of, let's say cancer, or reducing, bad blood cells in your body or whatnot. Here you're testing, you're testing. You want to know, wow, this curve is telling me right in this area at this particular, say, dosage, okay, or combination of what you're using is what works the best and minimizes the issue. So you want to know exactly what this point, okay? So you would, by finding the slope of the curve right here, this is what allows us to answer these things precisely, okay? They're called like maximum and minimum problems. So anyways, I'm sure this video went over 10 minutes, but hopefully you got something out of it, all right? This is the big deal with calculus. It is a big deal. It's a huge deal, okay? But uh, it's not impossible to learn. Even if you don't have a math background where you're like super strong in math and you struggle in math, you can get through calculus. All right, you can definitely get through calculus, but it does require you to study a lot of rules. And the best way to approach it though is to understand the value of calculus. So remember, the two big things that we study calculus for is to help us with these area and volume problems. That's huge. Okay, we use the integral for that. All right, and then the other thing is to find the slope. Okay, call this the derivative. So we use this symbol. Okay, all right, or this symbol, y prime, or this symbol. There's multiple symbols that mean the same thing. Okay. All right, so hopefully you got something out of this video. For those of you out there who are taking calculus, know a lot about this, and you're saying, oh, well, this is not technically correct or this and that. Well, listen, trust me, I have a math background, I have a degree in math, so that's not the point. I'm talking to people out there who, don't have a clue about calculus or interested in it. But anyways, thanks for watching, and if you like this video, please subscribe to my channel. Have a great day.